Join. Okay, so as per today's discussion, right, I want to give a high-level overview on what is Snowflake and how the traditional data warehouse has been started and how Snowflake is becoming one of the cloud data warehouse and that too in the which is a leader in the cloud data warehousing side. I want to go and give some overview. And if you have any specific questions, you can ask me in the last 5 to 10 minutes, and I'll try to answer your queries. So let me share my screen. Please let me know you're able to see my screen.
Yes.
Okay. So when I talk about Snowflake and before like going to Snowflake, we need to understand first of all what is a data warehouse, because data warehouse is not a new term. So data warehouse tools, data warehousing tools were available for a while, but when you see the data engineering, when it started, initially there was no any particular databases or data warehouses or data lakes. Nothing was available. When people started storing data, initially the industry was using electronic files to store the data. There was no any database, and these particular files people use it to store and they will used to retrieve for some time. And as soon as when people started thinking about how to store this data in a separate database, that is where the first database DBase came into picture. So DBase is the first database where people started using in 1980s, and that is also a command and interface. When they started storing the data, and they also started retrieving and manipulating the data, especially banking sector started using this particular DBase is the first database, and the same DBase which was in the command line interface has been upgraded to graphical user interface, and which got named as FoxPro. And this FoxPro became very popular in 1990s before Oracle was there, and every bank started using that, and every bank started creating their own databases using this particular software, and commercially it was very success. And up to 90, 91, 92 and 93, until Oracle became famous, FoxPro was very popular, and it also has been upgraded to Visual FoxPro as well. And slowly, what happened when Oracle came into the market with high security and extra features, where the customers are looking for, it eliminated FoxPro from the market, and Oracle became the leader. And along with Oracle, we got other databases also with the same similar kind of features. Like we got Sybase, we got like MySQL, Postgres, many SQL Server, many different databases came. But the objective of all these databases is ingest the data and then process it and store in the database only, in the database, and use it for the application development. That is what how the fundamental data engineering started. When people started using this particular Oracle and other databases, every company started building their own databases at enterprise level, and every company was success to create their own database environments with the help of the DBS, and the data also company started using to develop their applications, and also build some customer level features also. As soon as this was going very in a smooth manner, in end of 1990s and the initial stages of 2000s, every company started thinking about how to analyze the data. When the company started thinking about how to analyze the data, every company started using their existing real-time data, but which was frequently changing. So that was causing a difficulty to analyze. So the analysis was going wrong. So people started thinking, how can we go and keep or ensure the data reliability first, and how to maintain the data quality, because the data keep on changing. And the data keep on changing, we cannot do the analysis. How to make it available for mainly for the dashboards and reports and some part of analytics if they want to perform, and how to convert the data which they centralized into drive the business revenue. So that is what every company started thinking about. When people started thinking about, the databases has been slowly converted and migrated to data warehouse. The OLTP was there. At the same time, OLAP came in the market. The OLAP with its unique features, with historical data and column-oriented and high-performance reportings, all were possible in the data warehouse. So the data warehouse, the birth of data warehouse happened in early 2000s, where every company started utilizing the existing real-time data in OLTP, which is like e-commerce transactions, daily finance and business transactions. All companies started extracting and storing in a separate environment with historical data, that too not live data. And they started calling that as a data warehouse. And this data warehouse also, how people were leveraging data warehouse, how they're building. Informatica was one of the popular tools. And Informatica, data stage, and business objects, these tools, they started capturing the market in the ETL space. And even the sources for this data warehouse also was only structured data. There was no any semi-structured, unstructured, and quasi-structured data, because majority data in before 2000 was only structured rows and columns, especially in the CSV flat files and the database tables. And companies to build a Oracle data warehouse or a SQL Server data warehouse or a PostgreSQL data warehouse. So the data warehouse initially was only with structured data. And this was going in a very healthy and smooth runway. But coming to like in early 2010, suddenly there was a big revolution in the data side. There was a high data growth which happened suddenly, and every company started experiencing a huge amount of data, and that was causing the data warehouses to be very difficult to maintain. And every company started experiencing high burden in the infrastructure cost and storage cost and processing everything. Do you know what is the reason for high data growth suddenly in early 2012, 13 and 14? Suddenly? Any idea? Yamini? Or Harita? Or Madhu? Why there was a sudden data growth happened in early 2012 and 13?
Because of internet.
Internet is one reason, correct. Agree. The internet utilization increased suddenly. At the same time, the social media also increased, right? After 2012. So there was no social media that those many applications before 2012. As soon as Facebook became success, we got other social media applications: LinkedIn, WhatsApp, YouTube, Instagram, Twitter. Many different social media applications has been started, and these applications also started generating the data. But this data, what they were generating is not only structured, right? Everybody has a mobile, so they will go and upload images, videos, documents, and majority started uploading unstructured data mainly. When you see unstructured data like videos and images, the data growth will be very, very high. But I cannot store the such kind of data in the traditional data warehouse, because the traditional data warehouse or databases were designed for storing only structured data. So the industry slowly moved to the big data tools. So big data environments have been started by companies by using Hadoop and other tools to build a data warehouse which is converted to a big data warehouse. A big data warehouse is also a traditional data warehouse which converted with a huge volume of data and different varieties of data with high velocity. Plus, a big data warehouse slowly converted to big data lake also. So a big data lake is a place where you will have not only structured, it will also have unstructured data also. And it can store any kind of data, any volume of data with any velocity, high velocity. So IoT devices, weblogs, and so much unstructured data has been stored in these big data lakes, and which was utilized by data science and machine learning teams and data analytics teams extensively. Only after 2012 we saw this data science also became very popular. Before 2012 there was data science but nobody was caring about it. So data science became popular only after 2012, where the big data applications have been started, and all this started building mainly the high efficient data lakes, and every company started building their own enterprise level data warehouses, and then on top of that people started utilizing these data warehouses were there, but slowly every company started building their enterprise level data lakes also. But coming to data warehouses, how a data warehouse, traditional data warehouse will be built? A traditional data warehouse will be created by following all these sources, combined sources, and pushed into a operational data store. From here, you will have a staging area, and using the staging area, the transformations will be applied and pushed into the warehouse. And this warehouse will be again sometimes divided into separate data marts according to the department. Sales data mart, finance data mart, and admin data mart. So like that, you account data mart, like that you will have multiple subparts, and every data mart will be utilized by the respective dashboard teams to build their the teams dashboards also. Like sales data mart will be used to build sales dashboards. Finance data mart will be used for building finance dashboards. So these reports and dashboards are department oriented. The end users who use them, by leveraging this data, they will try to take some conclusions also. So the ETL was happening from here to here, and this particular area is for business intelligence reports to be developed. So if you see, the traditional data warehouse or ETL process was happening like this, and as soon as the data engineers who were working on databases, they slowly moved to the ETL and ETL to big data. So this is what every data engineers are doing. Extract the data, transform it, and load into the target. But the tools got changed in every time. Initially, people were using databases to perform this. After 2000, people start using ETL tools, Informatica and other tools. And after 2010, big data came into the same place. And slowly what happened? After 2020 onwards, or we can say not even 20, 15 onwards, or 16, 17 onwards, we got cloud tools also, like AWS Cloud, Azure Cloud, Snowflake Cloud. Many different cloud services came into the market to maintain your data lakes in the cloud. End-to-end data engineering in cloud and build enterprise level cloud data lakes. And whoever wants to use it, they also need to connect using the cloud ETL tools also, and to transform it and generate data and build cloud dashboards. That is what everything is cloud now. So every data engineer has to work on data pipeline design and development, data integration and modeling, building data warehouse with storage optimization, plus important thing is maintaining the data quality and the data governance. This is very important if you go to any project. So data sensitivity, how you go and perform the data quality or data validations, plus how you will ensure or enforce data security and compliance. All these are important, and whatever you see, these are all the current modern data engineer responsibilities. The data engineer role has been changed now, not like earlier. When you come and see, most of the data engineers, the modern data engineers are not only working on a single tool, not only Snowflake, they may work on other integrated tools like DBT, AWS, and then Python and Airflow. All these people have to use as a combination. Orchestration, for example, I need to use Airflow. And build a data warehouse, I need to use Snowflake. And to perform transformations, I need to use DBT. And for the data ingestion, I need to use Kafka or other data ingestion tools. So you need to use multiple tools here, not one tool. So we need to focus on all the required services and tools which are the market people are using. And if you see, this is an example of like how a real-time healthcare data will be coming from different sources. So if you go and see any healthcare system, the data will not be available in one place. The data will come from different locations. The public records will from government databases, patient portals, the data will come, wearable devices, where you go and wear some device which will track your health, or clinical data, outpatient visits, laboratories, pharmacy data, electronic health records. So every source here is not same. It may be JSON files, this can be XML files, this can be Excel file, this may come from CSV. So like that, every source is not same here. But as a data engineer, our responsibility to integrate all these sources and push into a centralized environment. How you are going to do, that is important, and what tools you are using, that is also important here. This is how I was talking about. The data is coming from different file formats. Research, CSV format. Clinical data, Excel. Labs in JSON format. Pharmacy, XML. Inpatient's record, like I am getting in CSV. But all we are consolidating and pushing into a centralized data repository. So we need to see how we can leverage Snowflake and other integrated tools to centralize this data. If at all assume you got a requirement to build a healthcare data warehouse, how you have to build, you have to know. But while building this data warehouse, you also need to see from where data is coming, because data in the market is growing every day. You can see here how the data has been started. I was talking about all this, remember. 2004 when Facebook started, that was the application which slowly became the impact of the data growth. Slowly after Facebook, we got YouTube, Twitter, WhatsApp, Instagram. See, every application here is impacting the data, enterprise universal data. And when the data increases, you also need to have the teams who can maintain that as well. And the data is coming from the internet in different sources. So data is very important, very useful in decision making, because every company has to know their customer preferences and interests to improve their business or increase their revenue. So they need customer data, because right information is important to drive your business, because that will optimize your revenue and your customers experience. So you also need to see more data, more analysis, more results, and more profits. Every company is targeting like this. So data will help you to increase the business value of the company. So capturing data and centralizing will help you in future. Because the customer, we don't know what customer will be interested or not interested. So we go to Amazon also, we don't know every time we go and buy the products. We just to go and do some kind of like body shopping, and we'll try to see if you're interested, you'll buy it. Not every time. So Amazon will try to track what are your actions in the website every time. When you visited their website, they will try to see which pages you visited, which products you selected. Your actions will be, your navigation will be tracked. And those actions will be analyzed by the Amazon team, and whatever the pages you visited and the products you selected, according to that, they will provide some recommendations. This will happen, right, with you? Most of the times, when you log in and go to any e-commerce website, whatever the products you selected, you will get some recommendations or not? My question. So they have to track
Yes.
they have to track your activities, right? They don't
Yeah.
track your activities, they cannot provide right recommendations to you. So this will be done with every customer, not only you. They will track what my actions, everybody's actions. Then only they can target you and they can recommend you something and you will buy and they will increase their revenue. So as part of this data engineering, you also need to do some kind of data cleaning also. Data cleaning means what? Whatever you see, this data, as of now, you can see the gender column, name column is good, but gender column is not looking good because somewhere it is male, somewhere it is M, somewhere it is MA, female also same, FEM, female, F like that. As a data engineer, our responsibility is to keep the data consistent like this. This is called data cleaning. Similar to that, this data also, you need to standardize the data. Name is looking good, but the age is not looking good. 22 years. For Ankit, it is showing 22 years, but Hema, it is showing as 300 months. And if you go and see Gopal, it is showing 25.43. We don't know what it is. And Shruti is showing as 20 years and 2 months. But the data is not standard here. Here we standardize it to all regards to single age column. We converted 22 years to 22, 300 months to 25 years. So every value we convert it into years. This is also one transformation which is called a data standardization process. We use standardization not only like this, we also will standardize the date formats also. Assume I want all the date columns should follow single date format. That is also one type of standardization. If you don't standardize, you cannot analyze easily, correct? No? Even my dashboard development also requires standardized data, right? If you go to Power BI or W, when you are building your dashboard, your data or date columns, you need to standardize. Then only you will see the right information every time. And since data is coming from different sources and it is generating huge amount of data, maintaining is also not easy because the data is coming in 4 different types in general: structured, semi-structured, quasi-structured, and unstructured. So structured means like our mainly structured. Unstructured means we know unstructured data is nothing but videos, documents, images, all will fall under unstructured. But semi-structured means XML files, JSON files. And quasi-structured means just now I mentioned about when you visit any website, they will capture your actions. This is basically will happen using a weblog file. That is quasi-structured. But structured data is rows and columns. So as a data engineer, I should be able to process any kind of data because data is growing every day like this. You can see from 2016 to now, my data is near to 175 zettabytes, which we cannot even manage. So every day we need to track because not every software will be able to manage. Oracle has a limitation, MySQL has a limitation, Excel has a limitation. We cannot go and use them if the data volume will grow. Some databases are not capable to manage huge amount of data also. So coming to like the challenges with traditional data warehouses mainly are the limited storage capacity, infrastructure burden, high cost. If you want to go and use the traditional data warehouse tools like Informatica and other tools, you have to pay license, which is not easy. And no scalability. I cannot increase or decrease the compute capacity. I cannot increase the storage also. And something goes wrong, suddenly something fails, you need to experience downtime. Security also some problem. So that is why the companies are slowly moving to the cloud data warehouses. The cloud data warehouses, why companies are moving also, the enterprise level traditional data warehouses and which are at the server level are not capable on many areas. Cost is very one of the burden. We need in upfront expenses. Data loss, sometimes risk of data loss, and the company cannot scale up and scale down, and also industry compliance. So there are some compliance issues also. We need extra IT support to maintain that, and performance bottlenecks will be there because we are maintaining huge amount of data. So every company, when they start using big data, they start experiencing the challenges because the developers got a big challenge to learn these many frameworks. Similar to that, the companies also started experiencing challenges to maintain this. So cloud computing came to the market. What is cloud computing? A cloud computing is a cost-effective environment with pay-as-you-go, with unlimited storage capacity, with automated backup and recovery, with flexible and pay-as-you-go and faster deployment. All are the features of cloud computing. So anywhere, from any device, anytime, I can access the data. So that is the main advantage of cloud computing, why companies slowly started moving. So in this particular area, AWS became the first cloud provider when they started their infrastructure services in 2006. They started with 2 services. Now you can see 200 plus services. Similar to that, the AWS, since it got success, we got Azure and GCP also. So coming to like that, the traditional data warehouses, since they have challenges, so these cloud data warehouses also came to the market like Snowflake, Redshift, BigQuery, all these slowly capturing market. And all these are cloud data warehouses, and we can call them as competitors also because they are very flexible, cost effective, and easily accessible and pay as you go. So these features are making them unique in the market, and out of all these, Snowflake is becoming the next generation of big data. Because Snowflake, why? Snowflake can manage not only like structured data, and it can manage semi-structured, unstructured data also. And Snowflake can easily learn because if you know SQL, it is easy to learn. But other tools you need to know minimum Python, Scala, or Java. If you don't know, I cannot go and learn or maintain big data environments. But Snowflake can easily maintain using SQL language. And live data streaming, if you go to big data, we use Kafka. And we have a Kafka connector in Snowflake also. And the stability of the product, if you see, big data ecosystem is very fragile. It will be keep on changing. But Snowflake is a single integrated product with all features are at one place. All the patching, upgrading, provisioning will be taken care by Snowflake team. So the product maintenance also very easy. But in big data side, you cannot do that. You need a separate team, dedicated team to do that. And you have to pay them also. And the performance optimization in big data side, you need manual intervention. But in case of Snowflake side, you do not need to do because that will be automated. And most of the people worry about how can we use transformations if the data volume is very high. In big data side, we have PySpark where it will help us to write some scripts to process huge amount of data. But in case of Snowflake, we have traditional cloud ETL tools. This like Matillion, DBT, Fivetran, all these tools are helping to transform Snowflake data and use some orchestration to create some data pipelines and extract, transform, and load the data into the target. And the supported size also, big data anyway it is unlimited. Even Snowflake also offering unlimited data. And the challenge with all this is either big data or Snowflake. If you go and see the market, but the big data is very challenging because we cannot find people that much easily who knows Linux administration and big data administration, because that is not easy. But I can easily find and train people into Snowflake because the people who knows SQL can easily learn Snowflake. We do not even need any other programming languages. Even if you want to use Python, you can use for extreme use cases, not every use case. And that is how Snowflake is becoming next generation of big data. Plus, coming to like why people are going to Snowflake also, because it is simple and scalable, instant elasticity, flexible cost, and diversity. Simple means I can simply create Snowflake account within 2 to 3 minutes and I can start using it. I need to use one existing Gmail and create account and log in and use it. That much fast it is. And scalability. The scalability is basically where I can scale up to any amount of data, any number of users, and any amount of workload. And Snowflake also offering instant elasticity where I can increase the size whenever I want. Even my SQL queries are running, I can increase and decrease the size. And coming to like cost wise, Snowflake is offering pay as you go. Use and pay. Whatever you are going to use, you need to pay for only for that. You do not need to pay anything extra. And flexibility and diversity. Diversity means you can store data in one place and we can access from multiple locations by using any device. So these are all making Snowflake unique in the market. And if at all I want to use Snowflake, it is very easy. You can go to the Snowflake website. There you can simply create the Snowflake account. If you go to Snowflake free trial, and it will prompt us to enter your username and password, and before that you need to enter your any of your Gmail. Mm, Gmail, let me use it. So you need to use any one Gmail which you most frequently use. I'm using this. Here you need to mention your Gmail here, and you can mention personal learning and development, and click on continue. Then it will ask us your company name. You can mention anything, and here you can keep the, and we have some Snowflake editions available. I'll discuss about them in detail in the further classes. Select for now as enterprise and select AWS cloud, and simply click on this checkbox and click on get started. So this will prompt you. All these you can skip them. That's it. Your account is created. And if you go back here, you might have received an email to activate. So the activation email, we need to go here. See, you received activate your Snowflake account. You need to click on this. And here you will receive a unique URL. Even you will receive, when you create your account, another one unique URL. You need to keep a handy. So click on activate and this will try to open. So I'll give So get started. So we just logged into Snowflake web interface. This is the modern Snowflake interface, which will allow you to maintain your Snowflake environment. So we can start directly clicking on SQL worksheet, and we can start using Snowflake from here. There are so many tabs here which we can go and use and maintain Snowflake. So I'm going to use a SQL file. And here, as of now, you see there are some default databases which Snowflake already created for us. Like Snowflake Learning DB, Snowflake is one database, Snowflake sample data, where they will provide some sample data also. What if I want to get my own database? I can use a command create database demo. So you need to press Control Enter and it will create. See, my database demo successfully created. If I refresh, I should see a demo database also, which will contain information schema and public. Two schemas by default. Every new database will have these two schemas. But this will be empty because this is a brand new database. So if I want to create a table, I can simply create a table also. So this is just like how you can play with this particular environment. I'm just showing you. ENO means employee number. I say ENT, ename, I'll say varchar of I'll say 50, and then I'll say salary float, and then semicolon, I'll enter, press Control Enter. So my table EMP created in this public schema. Okay. So I created the table, my table is ready. I can insert the data also. The commands are almost similar to other database SQL commands. DDL, DML, and all commands are almost same. There is no much difference. So I inserted one record. See, one record inserted with insert command into employee table using these three values. How to see the data? Select star from EMP. See, one record, 10, Paul, and 3000, you can see here. So we can use same SQL commands what we generally use in other databases. The basic SQL commands are same. And whatever the other SQL commands, you need to go and learn them step by step. And when you are willing to learn this Snowflake also, we are going to learn. So we are going to learn most of these topics, whatever you see here. So we go with the introduction, with some basic features, and also like what are the traditional data warehouse and how they are different from Snowflake is different from them. And we started creating an account also, and we go this process once again with, as of now, by default, Snowflake, whatever we created is a 30 days account. I'm going to show you how to create a 4 months account also. So we'll try to do that again. And after you created, and you will log in into Snowflake web interface, and we'll try to go with a Snowflake web interface tour, and we'll try to see what tabs available. And we also will try to see how to create the fundamental basic database objects like databases, warehouses, schemas, tables. We'll try to see some basic commands. And after that, we try to go and learn about Snowflake roles. And along with that, what are the different Snowflake accounts as well. And second module, we try to go and understand about what are the different cloud platforms Snowflake is offering. And we'll try to learn about the Snowflake architecture, three-layer architecture, and Snowflake pricing also we will need to understand. We'll try to learn about it. Along with that, we try to go and learn about the virtual warehouses and the caching also, which are interrelated. How Snowflake caching can help us to reduce the cost. We'll try to learn. And the third module is basically we focus on data loading and unloading into Snowflake, which will involve different types of files, how to load them from Snowflake internal stages and Snowflake external stages. And And this is basically to load different file formats, but we majority projects will use JSON, Parquet, and Avron ORC. We will try to go and see a little bit deeper about how to load this particular semi-structured data also. And this is going to be, until here, it is going to be a bulk loading. And whenever I want to perform continuous loading, I need to use NumPy, and we learn about it. And we also will learn about what are external tables and directory tables as well, and how to create them. And once after we finish that, we'll jump into the partner connect in Snowflake, and how to use different Snowflake partners, how to connect Snowflake with Python or Snowpark, and how to connect Snowflake with Power BI or with DBT or Fivetran or Police ETL. We will learn all these in the partner connector module. And after that, we move to the scheduling and incremental loading and scheduling part by using streams and tasks. And we also will learn about dynamic tables, which is the replacement of streams and tasks. After we finish this, we'll jump into the data governance topics like secure data sharing and dynamic data masking. Plus, we also will learn about how to clone the data and reduce the storage cost. That we are going to learn in the cloning module. And after you learn the cloning, we'll move to the time travel and failsafe, how to go and restore the data which you accidentally deleted or updated. And we try to see how cloning can be used with the time travel together. And we also need to understand about what are the table types, like transient tables and temporary tables and permanent tables, and what is the time travel period for them. And once you finish that, we jump into Snowflake views and what are the different types of views available. We will try to learn about it. And the 12th module is basically for query optimization and performance optimization. The clustering, we try to go and learn. Micro partitions, we also will go and touch upon a bit on query acceleration service and search optimization service also, which is not mentioned here because they are also part of performance tuning. And Snowflake Python connector is very important. I want to go a little bit deeper with some use case also. So I'm covering that in deep with some use case with in the 13th module. And Snowpark, which is also important. These two modules are very important, Snowpark and Snowflake Python connector. We are going to learn with some use case. And 15th module is how to create stored procedures and use different functions which are used for implementing programmatic way of SQL development. And once after you finish them, you jump into DBT, which is basically the data build tool for applying transformations on Snowflake data, and how to perform data quality checks and other stuff by using DBT and Snowflake integration. And the final module I want to go and discuss is Airflow with Snowflake and how to orchestrate Snowflake jobs using Airflow by integrating with the DBT. And once you finish that, we will try to learn about some projects here, whatever you see. And every project, whatever you see here, we are going to learn end to end with some examples and use cases. I mentioned here some architecture also, which you can see what projects and all we are going to learn as well. So that's what I want to cover in general. And with this is a 45 to 50 days training where we go and learn one by one each module with some use cases and examples, and you will have daily recordings in the Google Drive along with materials and assignments, everything. If you have any questions, you can ask now. Yamini, over to you. Any questions, Yamini?
Oh, no, nothing. So the Google Drive link you'll be sharing?
Yes. I will collect like the Gmails and I'll try to provide the access. Yes, correct.
Okay. Yeah, nothing for now. Yeah.
Okay. Are you able to understand what we discussed today?
Yes.
Yeah. Okay. Harita and Madhu, any queries or any questions from your side?
As of now, no, sir. It's
good.
Okay, Harita. If you have any specific questions, you can ping me and ask me.
Hello.
Yeah,
Hi,
Madhu.
Sri.
Hey, Madhu.
What is the Airflow, Sri? What is different between DBT and DBT is transformation, like you told, like
DBT is
and
basically for transforming the data,
okay,
but Airflow is to schedule it, scheduling the jobs,
orchestration.
orchestration. We have task available, but task has some limitations in Snowflake.
Okay,
So
okay,
to
okay,
overcome the limitations, we can use Airflow to schedule the data pipelines using Airflow, which is open source.
okay. So, but developing a pipelines, we'll do it in Airflow only or in Snowflake?
We write the code in Snowflake, but we call that as a Python script or SQL script using Airflow. Airflow
Okay,
can even schedule a SQL query or a Python script.
okay, okay.
So SQL operator will be there, Python operator will be there. So we need to use them to schedule these particular data pipelines. And each data pipeline is a combination of different steps, right? Stages.
Yes, yes.
So in the stages, in some stage it can be SQL script, or some stage it can be Python script, but we
Yeah,
can schedule them as a DAG, Airflow DAG, step by step.
Airflow tag. Okay, okay.
So that is
But important.
very popular open source orchestration now.
Okay. And in terms of DBT,
Mm, mm,
you said transformations, but we
mm.
do all the transformations in Snowflake itself. But why
That's
do we
what
need
that is what
DBT?
I'm telling. Snowflake we can do, but you cannot use every time the Snowflake compute, right? So we need to
Okay,
also use some tools where I can go and perform some data quality checks or data like validations and data transformations, where I can create this just like a SQL query in DBT.
okay.
So we can apply them and it will go and generate them, and it will generate even the documentation also on what you did.
And then it loading into the Snowflake table.
Exactly, correct. It will create
Oh,
as a separate table or a view also, finally.
oh, okay, perfect. Thanks. And
Yeah.
last question, you
Mm.
told me about live streaming
Uh,
data.
uh.
You are, I think in Snowflake and DB, whatever, the
Mhm.
big data, it using
Kafka,
Kafka.
Kafka,
Yeah.
correct.
What is that actually? Are we
Live
covering?
data. See, for example, assume I want to build a real-time dashboard. I want
Yeah.
to see my money landing transactions daily basis on a real-time dashboard. So I want to see which are part of money landing, which are not, for example.
Okay.
If I got some bank transactions, immediately I want to flag them on fly. It is a part of money landing or not. So live dashboards. I want to create a live dashboard, real-time dashboard. So in such scenarios, I need to get the live data on fly. So
Yes.
we need to use Kafka, or we have Kinesis, we have like Flink, we also have like Storm. So all these will help us to capture live data, and we can apply some transformations on that, and I can push into the Snowflake also.
Okay. Okay.
Yeah.
So are you covering this part of that as well?
Yes. As part of use case, correct.
Okay, perfect. Thank you.
No problem. If you have any other questions, you can ask. So no questions? Are we good? Okay then. We'll connect tomorrow at the same time, and we'll learn about some part of Snowflake architecture and some basic features of like examples, basic examples. That's all for today. Thanks so much.
Thanks, Sri. Thank you.
Thank you.
Thank you.
Thank you.